Hello everyone. In this lesson, we are going to answer a powerful question. Where does the distance formula truly come from? It's not magic. It comes straight from the Pythagoras. Okay? And let's go ahead and prove that step by step. Now, right here on the board, here's an XY plane. The horizontal side or axis is the x-axis with 2 points, x1 and x2, and the horizontal side, which is the y-axis, has 2 points which are y1 and y2. And from the way the points are labeled on the plane, this clearly tells you x2 is bigger than or is greater than x1. That is, x2 is greater than x1 and y2 also greater than y1. Okay, so let's say we want to find this side or the distance of the sides of the right angle triangle. Now, why is this a right angle triangle? This is a right angle triangle because if we bring in an imaginary line that connects the y-axis and the x-axis, now it forms a figure known as a right angle triangle, and that side of the imaginary line is the longest side of that right angle triangle, and so it's called the hypotenuse. All right, so if we want to see how we can move from point x1 to point x2, that's going to be the magnitude of these 2 points. Magnitude simply means distance. Okay, so we have the magnitude of the horizontal sides. The magnitude of the horizontal side gives us x2 minus x1, okay? And the magnitude of the vertical sides gives us y2 minus y1. Is that okay? And so, now, what does the Pythagoras Theorem say? The Pythagoras Theorem says that in a right angle triangle, the square of the hypotenuse is equal to the square of the base plus the square of the height. Now, if we go back to our figure, the height here is these sides, this magnitude, the y. The height is the y-axis, and the base is the x-axis. So the magnitude of these two sides are given by the magnitude for the y. For the height here is y2 minus y1, and the magnitude for the base here is x2 minus x1. So if we apply the Pythagoras formula, we have, if we apply the Pythagoras formula, given that the square of the hypotenuse of a right angle triangle is equal to the square of its base plus its height. Now, mathematically, if we introduce a square root sign to both sides of this equation, the square root sign cancels here with h, and we have the hypotenuse to be the square root of the sum of b squared and h squared. Now, so apply that to our figure. We have that h, the hypotenuse, is the distance, the square root of the distance of the vertical side plus the horizontal side. Horizontal side here. this is x2 minus x1. x2 minus x1, like that. And that is the Pythagoras formula. So for a quick example, what's the distance between the points A and B where we're given by, so if we can easily look at this and represent it on an xy plane, and the distance AB, which is the hypotenuse, is going to be given by the square root of 5, which is the first 5, which is x2. This represents x2. You know, you could start with y2 minus y1 all that squared, but here we started with x2 minus x1, which is 1 all that squared, plus y2, which is 5, minus y1, which is 2 all that squared, and all of that gives us 5 minus 1 is 4, 4 squared is 16, plus 5 minus 2 is 3, 3 squared is 9, 16 plus 9 gives us root of 25, and that gives us plus or minus 5. Now notice a distance cannot be negative, okay? A distance is not negative, and that is why our answer finally is 5, positive 5. So we choose this and reject this. So the distance formula is a Pythagoras in disguise. If this helped you understand, like this video, share with your friends, and drop a comment.